Welcome! In this lesson, we will learn how to simulate and analyze based on a completely built model. We can also give a general view on how to make reports. In this practice, I will use the simple elevator.m model. Open the model. This properly built model has all the components and lines with complete connection. Click on the Simulation tab. After the system compilation is finished, run and execute the simulation. The first thing we want to do is analyzing the system behavior. Click on the counterweight mass. In Variables window, drag and drop the displacement at port 1 into the sketch. Click on the cabin mass. Drag and drop the displacement at port 1 into the sketch. In plot 1, we can see that the counterweight drops from 4 meter to 0 meter in around 7 seconds. In plot 2, the cabin mass is moving in the opposite direction. In order to validate the influence of the shear frictions, we will use Study Manager to perform batch runs with global parameters. Click on Global Parameters. In the dialog, right-click on the blank and select New, Real Parameter. Type in a new name, COVF. Title, Coefficient of Viscous Friction. Value, 2. And unit, Newton meter per rel per minute. Apply. Click on Study Manager button. Then drag the COVF parameter into Study Parameters. Switch to Studies to set a user-defined dataset. Click Add to add another two sets and set the value to 1 and 3 respectively. Here we set 3 values for the coefficient of viscous friction. Tick before the name and click OK to close the dialog. Click on the inertia icon and set the value of coefficient of viscous friction to COVF, which will be linked to the parameter. Click on Run Parameters and set the simulation type to Batch. Click on the Design Matrix button and we can review the parameter values in different runs. Click OK to close the dialog. Run the simulation, and 3 runs with different viscous values are performed. Right-click on the plot zone, select Graph, and set the result set mode to specific sets. Keep the 3 runs selected. Click OK to apply the settings. Do the same processing with plot 2. In plot 1 and plot 2, we can see different curves with respect to different viscous values. After a simulation, we always need to create a report. One way is to select the components and copy them using Ctrl+C. We could paste the content into PowerPoint, Word, email, and so on. For the plots, we can use Edit, Copy, or File, Export to Picture, then paste or save the picture. The other way is to create an HTML report. Do the following. In the File menu, select Model Documentation, Create. The following dialog box appears. As you can see, the name of the report is a default value. It's stored in the same directory as the model and has the same name as the model. When you click OK, the HTML report is generated. Display the report. We can see the detailed information are listed in the report. When the model is saved, you can access it through the model documentation, display menu item, or by right-clicking on the sketch and selecting Help from the contextual menu.